And it's like, how can two twins have different ages? It's paradoxical. Well, it turns out that it's not paradoxical if you pay careful attention to motion and reference frames and proper time and things like that. We won't go into that, but we will in the space and time course next year, this time next year, in spring. Okay, so this time zone paradox and the Barber paradox and the reference frame paradox and the twins paradox are not really paradoxes. They're just puzzles because the experts agree on how to solve these problems. Right? But we're working our way towards paradoxes that are the real thing. We mentioned Zener, that's still a bit of a paradox, so there's a lot of agreement among the experts on how to resolve Zener's paradoxes. There's what's called the standard solution, even if there are competing other solutions. But we won't, maybe that's for another philosophy club talk, we can talk about Zener. There is the Sorites paradox, sometimes called the paradox of the heap. Or the paradox about being bald, which is, if you've got a heap of sand, and you take away one grain of sand, you still got a heap, right? How can one grain of sand make a difference? Therefore, for any stage in having a heap, if you take away one grain, you get a heap. Therefore, no matter how much sand you take away from a heap, you'll always have a heap. No, that can't be right, right? Don't you run out of sand? That's the Sorites paradox, or the paradox of the heap. And it's stimulated a lot of research among logicians on how to solve that paradox. I have a solution to this paradox, and they won't let me publish my solution. And I don't understand why. I think it's a problem with the editors of the journals. But my solution is, quit thinking about the paradox of the heap. What problem is there? I keep sending this to journals, they won't publish.
So what are we supposed to do then? Just not?
Oh, no, I was kidding. No, we should think about this paradox. Do you want to think about it? I mean, there are competing solutions to this paradox. What went wrong with Dowden's silly reasoning about proving you can't get rid of a heap by taking grains of sand away from a heap of sand, by taking grains of sand away from the heap?
I think it's partly a linguistic problem because it's seeking to be a quantifier, but it's not an exact quantifier, it's actually a qualifier. So it's really hard to say when something is and isn't a heap because it's relativistic.
So the notion of heap is vague.
Yeah.
Yeah, so this actually, study of this paradox stimulated a whole new area of logic called the logic of vagueness. And there's a lot of, you might think, well, wait a minute, I'm talking about formal logic. Formal logic is like crisp, and it's like, there's no room for vagueness. Yes, as it was originally produced way back in the days of guys like Frege and Bertrand Russell. But since then, we've actually come up with how you can think very rigorously and precisely and crisply about fuzziness. We won't actually go there with that, but that is a path to getting the solution, or to getting a way out that doesn't have bad consequences. I mean, the idea is if you solve a paradox, there might be many ways out of a paradox, or potential solutions of a paradox, but you want one that doesn't lead to more trouble. You want to get out of the paradox without producing other paradoxes. And you don't want to have to throw away too much of your normal ways of reasoning just to solve a paradox. And Dowden had the worst solution of all, which is to quit thinking about the problem. And that throws away way too much. Okay, we have a paradox of modality. I don't know what you want to call it, but It doesn't really have a standard name, I don't think. 9 is greater than 4, right? Oh, but wait a minute. 9 is 8 plus 1. Therefore, by good reasoning, right, isn't 8 plus 1 greater than 4? You just substitute in. Okay? I mean, they teach you this kind of stuff in 5th grade or wherever. But let's see, if you go back and look at history, you don't have to go back and look at history, you can just look outside, not in a metropolitan area like this one where there's probably there's too much light at night, but in a good night sky, like if you take a trip on the ocean, you can really see darkness. There are 9 planets that are visible to the naked eye without using a binoculars and telescope. At least that was in ancient times, the way they viewed planets. So, we say 9 is the number of visible planets, meaning visible to the naked eye, right? Okay, so substituting into our 9 greater than 4, we can say the number of visible planets. Oh, just realized, left off the modality part. I was thinking about the history of astronomy and not what I should have been thinking about right there. Necessarily, 9 is greater than 4, right? I mean, that doesn't just happen to be so. It's like the world has to be like that, right? That's the way we use necessarily. So necessarily, 8 plus 1 is greater than 4. But now if I go back to this and I plug in for 9 the number of planets, then the number of planets, right, we can say necessarily the number of planets is greater than 4. But that can't be right. It's not necessary that, if I can use a theological metaphor, it's not necessary that God built the world with more than 4 planets, right? It just happened as a consequence of accidents way back.
Isn't it only possible that 9 is the number of visible planets because we only have evidence of one possible universe, and one or more possible universes possibly not necessarily? So can we substitute?
Okay, you might say there are other possible worlds.
Yeah.
Is that what you mean? And in others, there are
Well,
other
isn't
numbers
that
for the planets?
what modality suggests? Or when we use modal logic, aren't we talking about possible worlds? And
Saul Kripke made a great contribution to our discussion of modalities by saying, yes, you're talking about possible worlds. When you say necessarily 9 is greater than 4, he would say there's a way to interpret that in terms of possible worlds, which is that in all possible worlds, 9 is greater than 4. So in all possible worlds, 9 is greater than 4, but you wouldn't want to say in all possible worlds, the number of planets is greater than 4, because there could be a possible world with 3 planets visible to the naked eye.
Just making sure, the way this is set up, we're saying that necessarily the number of visible planets is 9.
Necessarily this.
Okay.
I wasn't thinking necessarily inside, but that's a paradox of, I call it the paradox of modality. I don't think it has a standard name. But this has led to a lot of original research in the logic of modalities, in what's called intentional logic, with an S instead of a T for intention. Okay, there's going to be a test. Okay, we're going to have a test next week on a weekday, and it's going to be a surprise. Okay, we're going to have a surprise test. Now think about it. Weekdays, that means like not counting Saturday and Sunday, right? Could it be on Friday? Well, it can't be on Friday, right? Because on Thursday night you haven't had a test, then you know for sure it's going to be on Friday. That won't be a surprise if you know for sure, right? So you can rule out Friday. Whoever gives you the test can't give it to you on Friday. But Thursday, yeah, maybe Thursday or Wednesday. Well, let's just look at Thursday. Come Wednesday night, you haven't had a test. You have to worry about Thursday and Friday. No, you've already worried about, you've already eliminated Friday, so it's got to be on Thursday. But then it won't be a surprise if you know that. So therefore, you can rule out Thursday and Friday. So forth. So you rule out, in this kind of reasoning, just keep going, you rule out all days of the week, and then the professor surprises you with a test on Wednesday. Oh, that's a paradox. It's called a paradox of the surprise examination. And I have a solution to this problem also. I sent it to a journal. My solution is drop the course. And they won't publish. It's like the second time I've been shot down. These clever ideas. We're keeping them out of the journals so they won't reach other people.
It's the Illuminati at work.
So, how is this really a paradox or a puzzle? I mean, by that, is there a clear solution to this problem that you think you can talk other people into? Okay, let's see. A paradox is an argument for a contradiction. There's nothing wrong with languages having contradictions in them. What's wrong is proving a contradiction. Otherwise, you just say contradictions are false, right? Well, I just proved a contradiction. I proved that, by using my little bit of reasoning here, that there can't be a surprise examination. But then we also know, and therefore can say, just from our ordinary life experience, hey, we can get surprised. Boom. You could reason as Dowden reasoned and then suddenly get surprised there's a test on Tuesday. So therefore, there both can and can't be a surprise examination. That's a contradiction. So we want to go back and say, all right, let's clean up. We've made some syntactic, semantic, fancy terms. We've made some bad assumptions. We've reasoned improperly. Oh yeah, like where?
When is it a surprise? Because if this exam is next week, it could still be a surprise, but during that week it becomes less and less of a surprise.
That feels right to me. But didn't I prove to you earlier that not is it just less and less of a surprise, but that there will be zero surprise, because I've ruled out every day. So therefore there can't be any surprises.
This seems like women who are pregnant, like now we can have an ultrasound, and a lot of couples choose not to do that because they want to be surprised.
Surprise, yeah.
But it's still a surprise either way. Like whether or not you find out through an ultrasound or you wait, like you're still going to find out the sex of the child, but like does it really matter when? Seems to be the same. I don't think it matters. It's going to be a surprise when it comes.
Does that get us out of the problem?
Just
You have to start from having information from the fourth day to rule out Friday, or from Thursday to rule out Friday. And then once you've ruled out Friday, you need information from Wednesday to rule out Thursday. But as you're going along, you don't have the information from the fourth day to know that it can't be on Friday, so will still be a surprise which day following it will be, unless you make it to Thursday, in which case there's not a surprise exam, there's just an exam.
So if you talk about it in terms of information, you can conclude that there can be a surprise, and it's a mistake to say there can't be a surprise. Is that what your conclusion is?
Yeah.
Does that sound okay?
I think if you bring in terms of context like time, so at it'll be a surprise from T1, and so under all conditions of time 1, when it's initially said that it's going to be a surprise, it will fulfill those conditions. But those conditions might change over the course of the week, but that's no longer at T1. So even though it's no longer a surprise at T1, it's still a surprise from T1.
Is this T1?
Whenever it's stated that there will be a surprise exam. Because new information towards the surprise results, but it's not the same definition because it's surprise at T1.
Oh,